This is an inverse functions quiz review. And on this quiz there were 5 problems. We're going to go over all of these problems. The first one, the inverse function of f of x, f negative 1 of x, that's inverse function notation, is f negative 1 of x equals 1/3 x minus 2, which function represents f of x. So there are different ways to do this. One thing you do is you could take each of these answer choices, take the inverse of each of these answer choices, see which one gives you this one 1/3 x minus 2. But the easiest way would be to take this function right here and take the inverse of this function algebraically and see which one of the answer choices is matched. And so to do that, I'm going to rewrite this function up here as y equals 1/3 x minus 2. Now in the 4-step process of finding inverse function, this would be step 2, first step. Actually, it would be first step. Next step would be to take x equals 1/3 y minus 2. So switch x's and y's. And now step 3 is to solve for y. So if we add 2 to both sides of this equation, we end up on the right side with 1/3 y equals x plus 2. And I'm going to come up here and write this 1/3 y equals x plus 2. And we're going to need to clear out this 1/3, and do that if we multiply both sides of this equation by 3, and then we have to multiply the right side by 3. So we have 3/3 cancel the left side. And so what we have is y, as in 1y, equals 3x plus 6. And so that would be answer choice A. Now, I think, just looking through answers, I think a lot of people picked answer C. No, it's not answer C. So I think here's one thing, that we went over this quite extensively right before this quiz, and so it's just, I think, laziness if you didn't take the time to get this one right, because it should have been easily obtainable. Next, point 2 comma negative 6 is graphed on a coordinate plane. Which coordinate represents its inverse? Well, basically what you have for an inverse function is x's become y and y's become x's. So really, to make an inverse out of this guy, we take this negative 6, which is the y value, comes here, and its inverse becomes the x value, negative 6. And then conversely, this x value of 2 becomes the y value, and its inverse of 2. So x's and y's are switched, and therefore your correct answer is D. Should have been pretty easy. 3, very much the same, very similar to problem number 2. You're given coordinate pairs, and what we can do is, the only challenge is that you have the graphical representation in the original image, triangle ABC, and to find its inverse, well, if we can just put what these coordinates are for the original coordinates, we have, let's see, 2 to the right, 3 up. So 2 comma 3 is coordinate A. Coordinate B is 2 to the right and 8 up. So 2 comma 8 are the coordinates of B. And for C, those coordinates are 1, 2, 3, 4 to the right and 6 up. So 4 comma 6. And so you're looking for the coordinate switched. And for answer choice C, that's going to be our correct answer. Another way you could look at it is you could take the line here, y equals x, kind of a graphical way of looking at it. And just draw that line y equals x right up here. This black line is y equals x. And so you're looking at your being a reflection about this line. So we have the point A's reflection here, point C's reflection here, and B is going to be, just flip around, and it should be about right here. And so you can see that this inverse function here reflected about the line y equals x in this blue sketch triangle. Problem 4, the graph of f of x is shown below. And historically, this has been the hardest one of this quiz over the years. Again, it's really the whole thing. X's become y's and y's become x's for inverse relations functions. So what you're looking for is you have a y-intercept of about 3 on this original function. Say y-intercept equals 3. That's approximately 3. And so what you're looking for is, where do you find an x-intercept of 3? Well, not B. Now B is about 5 or so. Looks like D is about 5. And then look at the x-intercept. The x-intercept becomes the y-intercept of its inverse. So your x-intercept is about -5. Well, here you have a y-intercept of -5. And so I'm just going to draw arrows here. Okay, the y-intercept is the same as the x-intercept in its inverse, and the x-intercept is the same as the y-intercept in its inverse. So our answer choice is A. Now, I had a lot of people pick D. Now, one thing in inverse linear relations, if you have a linear function, its inverse function is going to have the same sign of the slope. And so you're not going to have a positive slope original function and have a negative slope of its inverse, because you're not going to change signs in the inverse. Yeah, you can have, you won't change the slope of the inverse. You can change signs, possibly, depending on where it is. Last one, problem 5, and this is one that kind of causes some thought. It's really is, make sure I move this over here, make sure it gets in our view screen. What you're looking for, the whole situation of coordinates switched. And so if you take this first one, -2, -7, well then, to find its inverse in the table form, you would look for an input of -7. And you don't see any such thing here of an input of -7. So we just have to go on to the next one. Well, then you take the next point, -1, -5, and then we look for an input in its inverse of -5. We don't see it. So these first 2 points are really inconclusive. Now we take the next point here, 0, -3, and we look for an input of -3, and we don't see anything. And so these first 3 points are inconclusive. They don't really help us at all. Next, we come to this 1, -1. So we look for an input of -1. And then if we have an input of -1, we have to have an output of 1 if we're switched. So I'm looking for the coordinate pair, -1, 1. And the only place I see that is this answer choice B, right here. Just for confirmation, we have this point 2, 1. We're looking for the point 1, 2. And we find it right here in answer choice B, and nowhere else. And lastly, we have the point 3, 3, and its inverse is going to be x and y position switched, 3, 3. So the only data set where we have any inverse points in common is this answer choice B. So that's it. Good luck on your continuing understanding and working out inverse function problems. And thanks for viewing.